Hello. This is the sixth programming assignment, which is a peer-to-peer network with one client or multiple clients known as peers and one server known as the host. The host server. So let's first look at what is going on the server. So here we have an object that is set up for communication between client and server. Here we have a basic interface or interface implementation for the messages that will be sent between the client and the server. Here is the interface for those objects. And here is a class that is used to keep track of the clients connected to the server program. So looking into the server, we first state that the server is running. Then we are going to open up a thread to keep track of connections to the server, and we'll get into that a little bit more in a second. After that, we just listen for keyboard messages that may occur. We're looking to see if a quit is sent or a member's message is sent. And here is just the basic implementation for the server requests. So now we're back into the point of creating the individual thread that is being used to listen for client connections. So what this does is it seeks client connections, and when it receives one, it will create a new thread for that individual connection. So now let's jump down to that. Oh, and we also add to our client list that a new client has been added. So now let's quickly discuss what's happening on the server thread. A new server thread is created. The first thing we're going to do is check if there has been any clients created to create a client host. If not, then we will let that client know that it needs to be the client host. If not, we will route that client to one of the client hosts that exists. This selection happens randomly, as we can see here. Here, we are just going to listen to the individual connections to the clients. That way we can know if it's time to quit the connection. So now we can jump over to the client or the individual peers of the peer-to-peer network. Here, we see the implementation of the RPC request that's going to be used between the clients, the individual clients themselves, and the clients to the servers. Here is the implementation for methods that we're going to need. Here is the main part of the application that runs the actual program. And here we again have the client list that is used to keep track of the individual clients that are in the application. So the first thing we're going to do is open a connection to the host if it's available. That way we know we can join the P2P network. Then we are going to add a listener to the host. That way we know if it shuts down and no longer try to contact it. Then after that, we are going to see if there is any, or if there's an IP address that is returned from the host. And if there's not, we will set this client up as the host peer. And if there is, then we will connect to the host peer if it's possible. If it's not, because there are too many connections to that host peer, a total of 3, we will then drop the connection and attempt to connect to one of the children of the client host that was sent to us from the server. This is done through the client host. The client host will send us another IP address. We will also add a listener to the client host to make sure we can successfully show a message if it has been deleted or not. And then we're also going to set up a individual server thread. That way we can listen for potential clients also trying to join the P2P network via this node. Then if we continue on that, we're just listening here to see if we're asked to quit. If we are, then we'll quit the process. If not, then we will return the individual connections to this client. Here, this is used to alert the children sockets that the host is closing, so they will need to drop the connection. Here is a little success message for the individual children that join the host, any of the hosts. Here is the creation of the communication between clients and client and server. Here is the server wait thread. So this is just going to wait for potential other client connections to this to become a client host, this particular client to become a client host. To do that, we're going to check, do we have 3 neighbors already? If we do, then we are going to create a server thread, but we're not going to add them to our client list. This server thread is just used to communicate that there are already too many connections here, and we'll let the attempting connection know of another IP address that may be valid. So we'll jump back up to the client list in a quick second. We'll continue with the server thread. Here, we're just opening up the server thread. If there's not enough open connections, then we'll let the client that's attempting to connect join and welcome them. And if not, then we will send them to a random child of ours. We'll continue to listen to communication from the children. That way we know to close a socket or not to. So now we'll jump back up to that client listen. This client listen is just used to update the children if this particular client goes down. So let's run the program. So here we have the IP address for the server. we will connect the host. So what we see here is this is the creation of the host connection, and this is the server letting us know that a host has been connected. So then what happens here is this sends a request to the server, and the server responds with the IP address. The IP address 0.3 refers to the second EOS machine, where we can see that the EOS machine has a reference to the third EOS machine, the 0.4 here. And this is letting us know how many connections are on that particular host. This is a success message saying that you successfully joined the peer-to-peer network. So then here, we'll also enter the IP address. So this has also successfully joined the network. So we want to see the neighbors. We can see that it is on the third EOS machine. We can see that it is also aware of that. Here we can see that there's a list size of 3. So here are the individual machines. This is EOS 1 and EOS 2. And here we can see that this only has the connection to EOS 3. So let's, so we see that the socket has disconnected. You see that the socket has disconnected. So what happens here, we'll close that. We see that the socket has disconnected here. We see that this no longer has a connection to the host. And we see this also no longer has a connection to the host. We can still get our neighbors. We can still get our neighbors over here, and we can see that this is still aware of each other. So now we'll quit the host, and we can see that the host has quit, and we can also see that the host has quit over here. So successfully connected and disconnected. So let's add another machine so we can see another couple machines so we can see the connections change. So EOS 03, so we'll do EOS 04 and EOS 05. We'll restart our server, start our consumer app. Restart that consumer app. Restart that consumer app. Okay, so now we have 4 individual connections. Here we are going to set this up. That's going to be the host. We have 1 connection. We're going to set this up. we can see that we have 2 connections, that this has joined EOS 05. So now we're going to go over here, and we're going to see that we have 3 connections now, and we see that we have actually joined on EOS 04, and we'll jump over here and we'll join, and we see we again joined on EOS 04. And successfully quit, and everything shared across the connections.